Okay, so today we're going to go over surface area in this video, and basically we're going to use the previous section where we talked about arc length to help us. So imagine that you were trying to find, imagine that you were trying to find the length of this arc, and then you rotated this shape around, okay? So basically we're going to find that arc length right here, right? We're going to find that arc length. But if you rotate this object and make it three-dimensional, if you rotate this line, y equals f of x, and you make it three-dimensional, you end up with something that looks like a bell, right? So in previous sections, you've done this before. In previous sections, maybe in Calc 1 or Calc 2, depending on your teacher, you've done the shell method, you've done the disc washer method, and you would rotate things and you would try to find the volume, okay? However, this time what we're going to do is we're going to rotate this, and then we're going to pretend like we're wrapping a ribbon or almost like a piece of string all the way around the bell shape, okay? But we need to find out the thickness of that ribbon, and that's what we're going to use arc length for. But then that ribbon will have a certain length to it, and that's what we're going to multiply by the radius for, because the radius is, we're wrapping it around, right? So we're going to be able to deal with the circumference that we're wrapping around. So we're going to do 2 pi r times the arc length, okay? So that's the idea behind it. So we're first going to talk about surface area is equal, let me do this. So we're first going to talk about surface area, and that's going to be equal of our little slice to 2 pi, oops, I wrote this wrong, sorry about that, 2 pi times y, right? Because the radius from here to here, that distance, if we're going all the way up to the blue line up there, if we're going all the way up to here, this distance from here to here will always be y equals f of x. It will always be the height at any given time on that curve. So this is our radius right there, okay? So we're going to have surface area is equal to 2 pi times the radius y times the length of that slice, and that would be 1 plus f prime of x squared dx. Right, so I'm basically using the idea from the previous section, which was arc length, right? And then I'm multiplying it by circumference, basically, which is 2 pi r, right? So that's what we're going to deal with. And again, it's more of a memorization problem. You memorize the formula, and now that you have the formula, you plug stuff into it. But there's a little bit more stuff now, so you can your integration could possibly be harder. Now, here's the catch. This was just for that one little L that we have, that one little arc length. So we want to know for the entire shape, for the entire bell, what's the surface area. So that's where this next formula is going to come from. Remember, how many of these little L's could I create? I could create an infinite amount of them with an infinite amount of ribbons. You wrap all these ribbons around the shape, and you have the surface area, and you add them up. That's going to lead us to our formula for surface area. And that is going to be surface area of the whole shape will be equal to the integral from a to b of 2 pi r times L, right? And in this case, where L is equal to 1 plus f prime of x squared dx, depending on, axis of rotation. And then it could also be 1 plus g prime of y dy, where I guess I should say it like this. Axis of rotation is y, or the y-axis, okay? So your main job will be to determine R and to determine L, right? So we're going to use this formula, and let's see what we got for an example problem. So it should feel very similar to the previous set of problems. And normally, just a hint, Whatever they ask you to integrate from, if it's in terms of X's or in terms of Y, that probably is telling you that's the axis of rotation. Okay, so let's look at let's do this problem. So find the surface area generated when y equals 2 square roots of x between 1 is less than x is less than or equal to 2 is rotated about the x-axis. Yeah, let's go with x-axis. Okay. So first thing we got to do is we got to find our L, right? So in order to find L, we have to find the derivative. So we know that y prime is worth 2 times 1/2 times x to the negative 1/2, right? So that will end up being 1 over the square root of x. And that is my y prime. Okay. So then we have to plug all this into our formula. So we know that surface area equals 2 pi times the integral from 1 to 2 of, let's see here, what's our radius in this problem? Our radius is y, so we're going to have 2 square roots of x times the square root of, let's see here, 1 plus 1 over the square root of x, quantity squared, dx, right? And remember, all I'm doing is this is my L, this and this is my circumference, this is my R, and then this comes from the circumference formula, right? The wrapping around of the ribbon, so to speak. So now we have surface area equals 4 pi, let's just clean this up a little bit, square root of x times 1 plus 1 over x dx, right? We get rid of the square root. There's quite a few ways you could do this problem. Maybe pause the video now and see how you would try to integrate this. Direct U substitution doesn't look like it's going to work. So you might have to do a little manipulation. So I would pause the video, see what you can do, try it a few times, and then unpause it. All right, so hopefully you guys have tried it a few times, and hopefully if you were able to figure it out, let's see, which way do I want to do this? Again, there's a couple ways you could think about it. Well, what I could do is I could take the fact that this is the square root of x times another square root, and I could write it as one big square root. So this would become x times 1 plus 1 over x dx, right? I could just move this into here. And then this would become the square root of x plus 1 dx. Well, that's not so bad, okay? And technically, this is a nice easy u sub. This becomes x plus 1, du is equal to dx. So this is a nice easy u sub. This would become 4 pi, the integral of u to the 1/2 du. I'm going to write my limits of integration in terms of x, so I'll plug them in at the end. So this will become 4 pi times u to the 3/2 over 3/2 from, we need our limits of integration. So this is going to become 8 pi over 3. U was x plus 1, so this will become x plus 1 to the 3/2 power from 1 to 2. Okay, so let's see what we get. So we have surface area is equal to 8 pi over 3. Now when I plug 2 in there, the square root of 3 is square root of 3, so this will become 3 to the 3/2. This doesn't clean up very well. Minus f of a, which would be 2 to the 3/2. And that would be your exact answer. Now, you could do a decimal approximation on your calculator, but in general, that would be your final answer, I would say. I think even in the homework, sometimes they actually prefer you to leave it like this. But obviously, if they say, give me the decimal approximation, that would be what you do. Okay. So just to give you guys kind of a heads up on this, this isn't like the end all and be all. I think in the homework, I only gave you a few problems on this. I just wanted to give you guys a video for the homework, but it should be very similar to this. That's all I'm going to probably cover. This is not a huge part of what I'm going to be testing you on or quizzing you on, but I'll probably throw one on the quiz or something. And these surface area problems are going to come up, you know, in random spots down through the end of the semester. So you'll just have to refer back to your notes. But again, I just wanted to cover this. All right, you guys, that'll do it for this section. And I will see you in our next meeting.